Hello, Assalamu alaikum. My name is Mohammad Shakil Mahmud. Today I'm gonna present analysis of time series data. So uh, the course is time series analysis. So I will present first of all introduction, then I will talk about the time series plot and plotting real data. I will show on my slide, and I will show also stationary non-stationary by autocorrelation function, and also I will show autocorrelation function for differences data and PSCF for real data. And then after that I will talk about order selection, AR1 and MA1, AR2, and after that to forecast my real data. Then for the short forecasting, then I will estimate AIC and BIC. After that, finally, I will the conclusion. So the report addresses the issue how starting from a time series may be possible build a model fitted step which is able to reproduce the observed values and trying to predict future outcomes. Graphical analysis to identify an appropriate model AR or MA is utilized. We have downloaded the data sets. The data sets own 65 observations. We have dealt with our analysis with this work schema, plotting the real data set, finding trend and seasonality components, computing ACF, PCF in order to select a suitable model, parameter estimation of model fitted, testing if the model fitted is reasonable with observed data, which is a long box text, uh, and computing the prediction, adding the trend and the seasonality to real data to forecast future outcomes of the model fitted. Next, I will show my the plot of my data. Um, Here is the plot, which is increasing trend and non-stationary. Now I will show the PNACF, where it shows that ACF dies down slowly. We say that our data will be non-stationary. We will now we'll go for the difference as data is non-stationary. Now ACF for differencing data. Here we see that ACF for differencing data to identify the model where it is not dies down, so it becomes stationary. Here ACF cuts off in leg 1. And in this slide, figure 4 represents the PSCF for real data to identify the model. Here the model is not really good for the case where PSCF cuts off in leg 1. And now I will talk about the order selection for ARIMA 110 or autoregressive one. Here we see that in final estimation, p-value is less than 0.05, which is significant. Hello, Moto. Which is significant. But in long box text, p is greater than 0.05 is not significant. Due to these abnormalities, we can proceed with different method to get p-values. So p-values for constant is less than 0.05, and also AR autoregressive one order selection is less than 0.05. But in modified box long box chi-square statistics, we see that the p-values is greater than 0.05, which is not significant. Now we can check by considering ARIMA 110 or and its residual and fits. Here we see ACF for the residual, where there is no cuts off in the lag. We do not need to proceed modeling with the ACF for the residual. So now here again for by considering ARIMA 011, here we see that in the final estimation p is less than 0.05, which is significant. But in long box uh, um, we see that the p values is greater than 0.05 is not significant. Now we'll check ARIMA 2, ARIMA 2100, that means, or ARIMA 2. Here we see that the final estimation is greater than mm, 0.05, which is significant, which is not significant, but in Langbox text also it's its p value is greater than 0.1, which is not also significant. But now we will go for the estimation for MA1 and AR2. We will check that according to the principle of parsimony, the value of AIC and BIC for M1 uh, um, is better in MA1 or AR2. So here we see that the ARIMA MA for MA1, we see that AIC and BIC is lesser than ARIMA 2. So according to the principle of parsimony, yeah, MA1 will be the uh, best order selection for our forecasting. Now we have forecasted according to MA1. Even though the data is until 65, we will forecast three more values until 66, 67, 68. Here is the forecasted value. And finally, even though the data is not satisfied the Langbox text and ACF for the residual, the ARIMA 011 is still better for the time series analysis. Thank you so much.